Over the last few years, sea level rise has been accelerating. And this is only the start of a development which will change our coastlines dramatically.
It may be 10 meters of sea level rise.
What does the worst-case scenario look like?
Annual losses could be $1 trillion per year just in the coastal cities.
How much time do we have left to find solutions?
Some areas will be impossible to save.
So how are we supposed to defend ourselves against the sea?
We cannot engineer ourselves out of sea level rise.
Politicians have to act.
Geophysicist Klaus Jakob from Columbia University in New York is studying the risks posed by rising sea levels. New York is particularly threatened by sea level rise, and Jakob's research could prevent damage costing billions of dollars. In 2012, his work saw him included in Time magazine's list of the world's most important people. New York is regarded as a model and reference point for modern large cities. But the Big Apple has a problem.
Around the year 2000, some scientists here in New York got together, and we realized that we have to really raise the public awareness of the risks that are coming our way. We chose a generic 100-year storm coming into the city. On the computer, it was modeled. When he had the first results, we went back to our stakeholders and said, uh-oh, you have a problem. Look at this, what we got. And they said, oops.
New York's Achilles heel is that the city's lifelines run underground.
We found out, to our surprise, that it takes only about 40 minutes for the subway system to flood.
For a good 10 years, the simulation presented by Klaus Jakob and his colleagues was treated as mere scientific speculation. But Hurricane Sandy, which struck New York in 2012, turned the scientists' apocalyptic scenario into stark reality.
Take a look at the water actually just pouring over the seawall now.
100,000 buildings were flooded. There were 44 fatalities, and millions of people went without electricity for weeks on end. Hurricane Sandy caused damage totaling $19 billion. The city was literally in deep water. Statistically, such an extreme event should only be expected once in 100 years. But this assumption is no longer valid. In Klaus Jakob's opinion, even a slight rise in the sea level will be sufficient to cause flooding on this scale once again.
There are scenarios out for as much as 9 feet, 3 meters of sea level rise by the end of the century. And that's extremely scary.
Yet despite this growing risk, coastal engineers have calculated that urbanization and population growth are still taking place 4.5 times faster in coastal regions than in the interior of the country.
There are 136 coastal cities with more than 1 million people in the world. The population of those cities was about 400 million people, and about 10%, 40 million of those people actually live in the coastal floodplain with current sea levels.
Rising sea levels could change the world map. Venice, San Francisco, London, many major cities lie just above sea level. The ocean has become a threat. Unless protective measures are taken, whole towns will have to be abandoned. So far, the world's coastlines haven't changed all that much. Only occasionally does the sea advance beyond the shore, mainly when the storm tide occurs. But this is happening more and more often. Scientists at Siegen University in Germany see this as the first phase of a steadily accelerating process.
What we have observed on Germany's coast over the last few decades is that extreme water levels are occurring with far greater frequency than average water levels.
We still know too little about wave behavior at higher water levels. Sönke Dangendorf simulates this change in a wave channel. Because the seabed is rising, as the wave passes over it, it develops friction. The wave deforms and breaks. Normally, this happens before it reaches the coast.
We have found that when the sea level rises, because of the greater volume of water they are carrying, many waves, which would normally break well in front of a dike, can now reach it, greatly increasing the pressure on the dike and perhaps even surging over it.
A higher water level clearly amplifies wave power. The higher the water, the later the waves break, and the greater the force with which they strike a built-up coastline. Even a minor sea level rise can massively increase wave impact.
Let's assume we are today here with sea level. And here comes a storm along. So it floods everything that's at this elevation or below. But now we have sea level here. So we need only a smaller storm to flood the same area, or we get the same storm, it's much higher.
Even a sea level rise of just a few decimeters makes flooding no longer a once-in-a-century event, but a normal occurrence. In New York, a rise of around 1 meter results in repeated flooding. Entire megacities underwater. A science fiction scenario? Perhaps, as in this simulation? Or are we looking here at the future? Along with New York, lying just 6 meters above sea level, Hamburg is one of the cities most threatened. Up to now, protective measures have served as defense against storm tides. But when the sea level rises, Hamburg also faces a totally different problem: rain. Social scientist Beate Ratter studies risk awareness where climate change is concerned. She asked people in Hamburg what they see as the biggest threat to their city.
First and foremost, it's a storm tide. This stems from personal experience or from what they have heard from other people. Personal experience plays an extremely important role.
Her survey shows that 2 out of 3 people in Hamburg believe that the biggest threat to their city from climate change comes in the form of storm tides. After the horrific storm tide of 1962, the city adapted to the threat. Today, catwalks enable anyone living in an exposed area to reach the safety of protective walls without getting their feet wet. But warmer water and rising sea levels are speeding up the entire climate cycle. Extreme weather events will increase, like heavy rainfalls, for instance.
Basically, what happens with heavy rainfall events is that increased insulation over the ocean produces evaporation processes which cause moisture to rise into the atmosphere. Wind then blows this cloud of moisture towards the land. As long as the cloud is over the ocean, nothing happens. But when the cloud reaches something which causes it to rise, its retention capacity diminishes and rain then falls locally, for example, on Hamburg.
The whole of Hamburg underwater. Torrential rain could quickly prove too much for the city's drainage system. New storm-type walls are being built, but they still don't offer Hamburg adequate protection from the consequences of an accelerating weather cycle.
Here in Hamburg, we have what we call a risk perception paradox. People like to associate climate change with storm tides. So, because they are safe from them, they think they are also safe from climate change in general.
It's not only Hamburg that will have to face up to a new disaster scenario. The faster sea levels rise, the greater the influence this will have on the weather, with unforeseeable consequences. Ultimately, much will depend on the degree of sea level rise. But how can the sea level and changes to it be measured?
The first sea level measurements date back to the 17th century. Since roughly the middle of the 19th century, we have had 70 or 80 gauges worldwide, which we can use to determine the level of the ocean.
One of these gauges is on Heligoland. It has been measuring changes in the sea level ever since 1885. It has produced tens of thousands of data, which are stored in an archive in Tönning in northern Germany. This data treasure is the sole source available to researchers for determining with millimeter accuracy whether the annual sea level rise in Germany belongs to natural fluctuation or is already part of a long-term trend. The figures are clear. The sea level has been rising ever since we began measuring it.
Since the late 19th century, the sea level has been rising faster and faster, initially at a rate of 1 millimeter per year. But since the 1960s and 70s, it has been accelerating again, and the increase now stands at around 3 millimeters a year.
Historic data are also utilized in Hamburg. At the German Climate Research Center, the DKRZ, they form the basis for climate models. Here, future projections have been made ever since the late 80s.
Specialist scientific knowledge coupled with state-of-the-art computer technology enables complex model calculations to be made. With these simulations, scientists predict what impact the constant increase in greenhouse gases will have on the atmosphere and on ocean levels.
With each new generation of supercomputers, projections are getting more accurate. Beate Ratter, our specialist from Hamburg, is one of those who interpret this data for the Intergovernmental Panel on Climate Change. As a marine researcher, she's also the co-author of the last special report on the oceans. She knows the models exactly.
We have precise knowledge of what has happened over the last 100 years. We also know all about the physical processes concerning water and ice. But predicting the future is like looking into a crystal ball.
In order to predict sea level rise, first and foremost, temperature development must be taken into consideration. In addition, the interaction of various forces in the Earth system has to be calculated. Ultimately, however, one factor is paramount: human behavior.
How do we assume how society will behave? Because CO2 emissions, which drive climate change, are determined by society, and that is what makes everything so difficult.
For 2 years, a supercomputer was fed data for current projections. The development through to 2100 is presented in 3 scenarios, from a best to a worst case. Researchers have no problem explaining sea level rise to date. As the oceans heat up, the water expands. But a totally different element could soon become a driving force: ice. Researchers are concerned at the dynamics of the Greenland ice shield. As a result of global warming, the mass of ice which the shield releases into the ocean every year is increasing. Greenland's ice shield covers an enormous 1.8 million square kilometers. In some places, it's more than 1.6 kilometers thick and weighs around 2.7 million gigatons. Until well into the 1990s, the ice mass remained roughly constant. But since the turn of the century, on average, Greenland has been losing 266 gigatons of ice a year, and is thus contributing to the global rise in sea levels at a rate of 0.7 millimeters a year.
To envisage an extreme situation, we must assume that all the glaciers have melted along with all the ice masses in the Arctic and the Antarctic, and that this water has flown into the ocean. Then we have a rise in the sea level.
For years now, researchers have been warning of the impact of global warming on sea level rise. Predictions are constantly being revised upwards. For this century, the most pessimistic estimate by the Intergovernmental Panel on Climate Change is a rise of 1.10 meters. But even this figure is questionable. There seems to be no upward limit. Over 100 scientists from 36 countries played a part in producing the last special report on the ocean and cryosphere in a changing climate. It involved evaluating 7,000 publications from the last 5 years and resulted in a report running to some 800 pages.
And what will actually be done with the report? It was published with a lot of hype. There were numerous press releases and a press conference. But we merely took note of everything, and then the next World Climate Summit took place in Madrid and, well, it's not about knowledge, about even more accurate knowledge. Politicians couldn't give a hoot whether a glacier is melting at a rate of 2 or 3 millimeters a year. They decide on whether to impose restrictions on the car industry, like promoting electric vehicles. We have produced a vast amount of information over the last 15 years. What we have today is not an information deficit, but an action deficit.
Social scientists call this phenomenon the concept of psychological distance. You can't feel statistics. We distance ourselves from the fate of the individual, from the fate of small islands and coastal inhabitants. But how much longer can we continue to do that? Few cities depend more on exact forecasts for their existence than Venice. Some parts of Venice are not even 1 meter above water. Ever since sea level rise began to gather pace, the city has also suffered from increased flooding. Now every centimeter is of crucial importance.
In this moment, for the next century, Venice has a solution.
The Venetians are plagued by a trauma. In November 1966, the sea level rose to 1.80 meters. Scientists calculated that such an extreme storm tide would occur only once every 200 years. Even so, the city wanted to take defensive steps to prevent flooding on such a scale ever happening again. Engineers came up with a concept which, in an emergency, would isolate Venice's lagoon completely from the sea. This bulwark was given the name MOSE. MOSE lies on the seabed. Should a storm tide occur, 78 floodgates will be filled with air and forced upwards, closing the lagoon and sealing off the city from the sea. A brilliant solution. But MOSE has one drawback. It could be too low.
We have dimensioned the system considering the IPCC scenarios in the late 90s, and we have considered the worst scenarios, that is 60 centimeters of sea level rise in the next century.
But forecasts have changed. The prediction for this century is now a sea level rise of more than 1 meter. Then, MOSE, which cost €5.5 billion, would no longer be able to protect Venice.
If there will be 2 meters of sea level rise, we have to do something else, but not only Venice, the entire coastline in Italy and in the Mediterranean.
Its engineers have no time to lose. Even last winter, MOSE was already unable to keep water out of the city.
The last high tide in Venice was extremely high. It caught everyone by surprise.
Because of corruption and planning errors, the marine bulwark is still under construction. Even after 20 years, it's a political scandal.
And that in a threatening situation in which the people of Venice will have to face the consequences. Basically, they must expect high water and flooding 2 or 3 times a year for years to come.
According to a current report by the Intergovernmental Panel on Climate Change, if we don't reduce greenhouse gas emissions, a 2-meter rise in the sea level cannot be ruled out. Unless we manage to lower the CO2 content of the atmosphere, extreme events will become normal. Then, not only will Greenland's ice masses continue to melt, so will those in the Antarctic, where the ice shield has so far been regarded as more stable. The ice in the Antarctic contains enough water to cause the sea level to rise by 58 meters. The ice is pushing outwards, but is held back at anchor points. The shelf ice, as it's known, acts like a dam. When the temperature rises by 0.5 degrees, it melts from below and fractures on the edges. The anchor points detach and ice from the land pushes through. Around 1 billion people live in low-lying coastal regions. Will we ever be able to protect them from such enormous masses of water?
At the end of the day, coastal protection or flood protection is always a cost-benefit calculation. If costs continue to increase through sea level rise, at some point we will have to decide whether it still makes sense to protect certain regions or whether we should abandon them.
Robert Nichols plays a leading role in a totally new field of science: human adaptation to sea level rise.
Here we just have 10 centimetres of beer in a glass. Let's imagine that 10 centimetres of sea level rise. That can actually cause damage costs to rise maybe double. Some people even say go up 10 times what they are today if we do nothing. So it's something we can simply not ignore. Money is a key ingredient. I think it also comes down to what society thinks, your culture, your history. These are also things that shape your view on what is the best approach.
Great Britain, where Robert Nichols comes from, has already decided that, in some regions, there will be no further investment in coastal protection.
Based on our analyses of the shoreline management plans, about 500 kilometres of defences are expected to be abandoned over the coming sort of 50 to 100 years. And that really means in places people's communities having to be relocated inland.
Bosham on the south coast of England. At low tide, boats are stranded. Nevertheless, flooding will increase. In the long run, it seems, the people who live here will have no choice but to move out. Poorer societies will be hit much harder by sea level rise. The more resources that are available to a society, the easier it will be for it to protect itself and to finance resettlement in an emergency.
Britain has far more coastline than we have in Germany, and the relationship between the government and its citizens is also totally different. An announcement that resettlement will be necessary is almost inconceivable.
Unlike in Britain, at present no one in Germany would contemplate resettlement. Since preservation of the coasts is anchored in the German constitution, the country's 3,700 kilometers of coastline enjoy unconditional protection. It's clear that sea level rise has other consequences: more storms, more storm tides, and more torrential rain. Germany has the resources and the knowledge to protect itself. That might be adequate for the near future, but just how long will present measures prove effective? Are we not simply delaying the inevitable?
I think that adaptation in many ways is always about buying time. No adaptation lasts forever. So you build a wall. In 50 years, your children will have to make a decision. Do they rebuild that wall, or do they maybe give up on that wall and allow the sea to flood?
We still have solutions for the most likely scenarios in this century. But the further we look into the future, the more likely it seems that our coastal protection has its limits.
It is something that will only have a finite lifetime. Maybe if you stretch it, good for this century. And then what?
As a rule, the time horizon for forecasts and the protective measures resulting from them relate to the year 2100, because anything else just wouldn't be practicable. But this time limit is irrelevant to the oceans. They will continue to rise even after that.
I believe that humankind will still manage to adapt to certain things, but there will be losers.
Whether or not the ice shields in Greenland and the Antarctic collapse depends on us. But through causing temperatures on our planet to rise, the path towards this scenario has already been taken.
Paying lip service is no longer enough. Unless they result in action being taken, climate summits in Paris, Copenhagen or Glasgow will serve little purpose.
If we are to combat sea level rise, we will have to change our lifestyle. If we don't, we face losing entire habitats.